To better understand the properties of logs, we're going to do what we would often do in class, and that is to spend a second day visiting with the ideas and also extending them. Now, the properties that you see at the top of your paper, they're the same from yesterday. We have the product rule. The product rule says that when you're adding, that's going to be able to be condensed to be one log of a multiplication. And the quotient rule kind of says the same thing just for subtraction. You're going to be able to condense to one log, but you always use a fraction when you have subtraction. Now remember, whatever's being subtracted is really what goes in the denominator. Now, the power rule says that if you have a number out front, it's allowed to come up as an exponent. And just the same, if you have an exponent, it's able to come down front as a multiplier. Now, I put the change of base formula back into our notes because, as you might remember, I ended yesterday's lesson with mentioning that you have to be careful that you don't use the change of base formula when you think you're using the quotient rule. So the change of base formula says if I have a single log base b of x, I can calculate that by dividing two logs. Now, dividing two logs is different than just dividing x and y. So notice that the quotient rule and the change of base formula, they're kind of similar, but they're really referring to two different scenarios. Now, what I'd like to do is kind of go through just one more time, a few examples that match into each category. The idea here is that some of these examples will also just involve a little bit more, a few more steps, maybe something that we didn't quite get to show you yesterday. And so this is the extension part of today's lesson. Now, when you look at letter A, you definitely have to see that there's multiple logs. But before we can just try to write this as one log, we have to recognize that there's some algebra. And the algebra says that we would be multiplying or distributing a negative. And just like in any algebra problem, if you have a number in front of the parentheses, it distributes, it multiplies to now be in front of each of these logs. Make sure that the negative sign becomes part of that distributing. Now, as far as logarithms go, we want to understand that now we have coefficients, and coefficients always come up as exponents. This is called the power rule. So all these coefficients are going to come up and become squares on each of these variables. And now we're going to have, an x squared. Now we're going to have a 2 squared, and we're going to have a y squared. Now, I want you to notice something that I've done here, and that is that I did not bring the negative sign up as an exponent, because what I'm going to do here is use these negative signs, both of these negative signs, to help me to create a fraction. And that's the last step, which is to write my answer as one log with a fraction. So here's my one log. I'm getting ready for the fraction. Whatever is being subtracted, that is this 2 squared and this y squared, they're going to go in the bottom. Now, the 2 squared is really the number 4, so I'm going to change that. But now I have a 4 and a y squared in the bottom. Now, whatever is being added, that is this x squared, that's going to go in the top. And so I've condensed this to be the log of x squared divided by 4y squared. How about letter B? You actually have seen a few problems like this. This is on purpose that we could just kind of see this one more time. We definitely have coefficients. They have to come up as exponents, but you have to be kind of aware that these exponents, they're going to obviously be fractions. So what are you going to do? Well, let's do one thing at a time. Let's bring the 1/2 up as an exponent. Let's bring the 3/2 up as an exponent. Now, since these exponents are fractions, we've learned that the denominator is going to be the root. And so that means that we have square roots. That means I can write this as the square root of 8. Now, not to forget about the numerator, but since the numerator is 1, that would be like a power of 1 on that 8. I don't really need to show that because, of course, it's still 8. How about this x? It's going to be like the square root of x. Now, there is a numerator here. It's a 3, and so that 3 is actually going to be the power that goes on that x. So I have the square root of x cubed. Now, whenever you have square roots And of course, this addition sign says that I'm going to be able to combine these together to be one log. So since now I have these square roots, I'm able to put all of them under the square root. And so the 8 and the x cubes can be combined together. Again, notice that we have one log. Because we had an addition sign, we were able to multiply these together to be the square root of 8x cubed. All right, now before you guys get working away at that group of problems underneath, I want to continue to go through these examples with you so that we can expand upon and just help you better understand these properties of logs. Now, if you look at letter C, it's got a square root, and that's kind of fitting because we just got done talking about the fact that a square root is the same as an exponent. So what I'm going to do here is, just to save a little bit of time and space, I'm going to just change that square root to an exponent of 1/2. Knowing that now that 1/2 is going to be able to come down in front. So we're going to end up with a 1/2 in front of our log of x to the 5th y. Now notice that that was the first thing that I did, that I actually brought that exponent down as a coefficient. The reason that that was the first thing I did is because now I'm going to be able to deal with these two terms. And you want to recognize that since there's two terms, you're going to end up with two logs. If you would like, you can write the log twice, but understand that there was a 1/2 that, since it was in front of my original log, it actually has to be in front of both of these logs. I know that's a little bit trickier, but essentially the 1/2 from the very beginning was part of the whole problem, and so now it's part of both of these logs. Now, we only really have one other major thing to do, and that is to take these two items that are inside here, this x to the 5th and this y, and allow them to be part of splitting up into both of these logs. So I'm going to put the y, I'm going to split that one, and then the x to the 5th. Now, the x to the 5th's got this extra 5. Well, guess what? That 5 is actually going to scoot down in front. I don't want to say again, but we're going to have another number come in front again. So is it all right if I just put that 5 there now? If I put the 5 in front, it multiplies and becomes a 5/2. So we have two logs that are being added together. All the exponents went in front. The 1/2 is in front of both of them, but we get this 5 that's also in front of the log that contained that x. Letter D is actually a little bit easier because right away you can look at this and you can say we got 3 items. And since there's 3 items, we're going to have 3 logs. Now, 2 of the items are in the denominator, so both of those items are going to be part of subtracted logs. If you would like, you can just put the y with the first one. And if you like, you can put the x to the 3rd with the second one. But remember, the z to the 3rd, but remember that 3 is going to end up coming down in front. And sometimes students are ready just to write that number right away. So we end up with a subtraction of those two guys. And the only thing left to do is to put this x with the one that's being added. The reason it's being added is because we assume that there's a plus sign in front. So we end up with the log of x minus the log of y minus 3 log of z. Flip over to the back with me and you'll find an interesting application that we did not get to talk